Well, hello, lovely math students. Today we are going to be solving two-step equations, and this is 3.1 to 3.2 to 3.3. If we are solving two-step equations, it means we're going to isolate the variable by itself, and I like to say we simplify the left, we simplify the right, then we'll move across the equal sign. So if I look on my equal sign here, this is the left side, and this is the right side. Everything on the left is simplified and the right is simplified. So I'm going to go ahead and move across the equal sign. In order to do that, I notice that my x is on the left hand and that's what I want by itself. So first I'm going to move the number across the equal sign by using inverse operation. The opposite of addition is subtraction. So I have to subtract it on the left, and whatever I do on the left, I'm going to do on the right as well. That's the subtraction property of equality. So that's how that's canceled. Now I have 3x is equal to negative 9. Negative 5 minus 4, same signs we add, negative 9. Now to get x by itself, I'm going to do the opposite of multiplication, which is division. So I'm going to divide both sides by 3. And keep in mind I'm using the line for the division bar. And so x is equal to negative 9 divided by 3, which is negative 3. That is the value of x. So of course you could substitute to check. I'll check this one, but sometimes I'll just mentally check it with the calculator or my mind. So it would be 3 times negative 3 plus 4, that's equal to negative 5. I'm going to check in green. Negative 9 plus 4 should equal negative 5. And this is true. Negative 5 is indeed equal to negative 5. So I know that my solution is correct. Let's look at number Let's look at number 5. So we have x divided by 4 minus 3. It's equal to 7.2. If you remember in class, we talked about the bestie. They're together. So I have the left side and the right side of the equal sign. The left side is simplified because I cannot put negative 3 together with the x. And the right side is simplified because it's just the number. So to get x by itself, which is being divided by 4, I'm going to get rid of the extra thing out here first, the extra person. Or we know that negative 3 and 7.2, they are like terms. So I'm going to move the negative 3 across. I could only do that with inverse operation or opposite operation. So that cancels out. Now I have x divided by 4, and that's equal to 10.2. 7 plus 0.2 plus 3 is 10.2. Now to get x by itself, I'm going to multiply both sides by 4. Because it's the opposite of division, that's what's going to cancel that out. So now I'm left with 1x. And it's equal to 4 times 10.2, which is 40.8. So x is equal to 40.8. Now I can go ahead and substitute it to check, but I'm going to stay right there and call it a day. Now I want us to look at number 5 and see how it's different than number 6. Number 6 says x plus 3 divided by 2 is equal to 4. Everything on top, the whole numerator is being divided by 2. In this case, the first thing I would do is not subtract the 3, but it's going to be to get rid of the 2 because all of this is together on top. So I'm going to multiply by 2 first. So I could get my numerator, my entire expression, x plus 3, and that's going to be equal to 4 times 2, which is 8. Whatever I do to the left, I have to do to the right. Now it should come back to a one-step equation, and I will get rid of the 3. The opposite of addition is subtraction. So I would minus 3 on both sides, and now x is equal to 5. come on down. I want to do a fraction with you, just so we see what we would do. And I'm going to do 4/9 is equal to negative 2/3 plus 2/3 m. Yes, there's fraction, but it's actually the similar concept. This is hanging out with the variable. That's your m. That's what you want. So the first thing you're actually going to move is that negative 2/3. And the only way to move it is by adding 2/3 to both sides. Now, when you do that, adding fractions is a little weird, so I'm going to come on down to the side and do it. That's 4/9 plus 2/3. In order to add, you need a common denominator. The common denominator is going to be 9. So I need my equivalent fraction. That's 4/9. And 3 times 3 is 9. So 3 times 2 is 6. And that's going to give me 10/9 when I add them. So 4/9 plus 2/3 is equal to 10/9. And that's equal to 2/3 m. If at any time you need to pause to see what's happening, pause. If you need to slow me down, that's fine. If you want to speed me up, that's also fine. Now, in order to get m by itself, I'm going to do the inverse, right? So this is going to be divided by a fraction. But if you recall, to divide by a fraction is really to multiply by the reciprocal 3/2, or 3/2. That's what's going to make that 1m. And then, of course, now we have 30 over 2/9 18. So now we have 30 over 18. We can simplify that. I could divide both of them by 6. And so, what's this? 5/3 is equal to my m. And then I can make that my mixed number, which will give me 1 2/3 as my m. If you're in algebra, like 8th grade or so, we'll leave it improper as that 5/3 over m. In 7th grade, we will do that 1 2/3 equals m. Now, I want you to pause, and then I want you to try these problems on your own. Take a moment to pause and just try them. The only way to learn mathematics will be to do mathematics. All right, so now that you have worked on it, let's go ahead and try number 2. Your x is over here on the left side, and you want to get it by itself, but it's hanging out with the negative 3. Because this one's by itself, this is attached at 4x. I'm not going to move the 4 first, but I'm going to put the 3, which is like terms with the 9. I'm going to add 3 to both sides first. So now 4x is equal to 12. And this is now a one-step equation, like what we did before. And now we are going to get x by itself. The opposite of multiplication is division. So I divide both sides by 4, and x is equal to 3. On number 13, if it's a decimal, same process. Here is 2y. They're together, so I'm not doing that one first. I am actually going to get rid of the 6.3. The opposite of subtraction is addition, so I'm going to add 6.3 on both sides. And I'm going to put it with the number because they are like terms. So 2y is equal to 13.5. I want y by itself, again, to isolate, so I'm going to divide both sides by 2. I'm trying to find out what exactly is y. So y is equal to 13.5 divided by 2, which is that 6.75. Now let's look at number 4. I want to find m. If I look, I have my left side of the equation and my right side is the equal sign that we're crossing. Your m is on the right side with the 2. So in order to isolate the m, I'm going to get rid of the 2 first. I would have subtracted 2 on both sides. So that 15 is equal to 5m. Then I would divide both sides by 5, the opposite of multiplication, such that m is equal to 3. Now let's look at number 7, and we'll be done. It is a fraction, but don't let the fraction scare you. Same process. The negative 2/3 is with the m, so the 1/5 has to go first. I would subtract 1/5 on both sides, bringing it with the number because they are like terms. And now I have 2/3 m, and that's equal to 3/5 plus 1/5. I'm sorry, 3/5 minus 1/5, which will give me 2/5. Now to get m all by itself, I'm going to do the inverse, the opposite of multiplication, which is division. But when I divide by a fraction, I actually multiply by the reciprocal. That's what's going to give me 1m. And then I multiply straight across for a fraction. So 2 times 3 gives me 6. 5 times 2 gives me 10. And so your m is equal to 6 over 10. If I simplify, it is going to be equal to, divided by 2, 3/5. Right? Number 9, you can go, nope, I did number 9. Oh, we're all done. Oh, number 8, it would look like number 6. And remember, math really just looks alike. So once you have it, you practice it, you'll understand how to see the similarities. In order to learn your mathematics, remember you must do your mathematics.